So good morning. I'm Julie Lerman. I even had a nice picture of where I come from in the U.S. It's just a picture of the United States, you know, our huge country, way over in the upper right-hand corner, almost near Canada. I live in a tiny, tiny little state called Vermont. We're famous for Ben & Jerry's ice cream and Bernie Sanders. Yeah, everybody knows him now. Anyway, so what I'm going to be talking about today is combining two of my very deep passions. One is entity framework, and just out of curiosity, who here is familiar with entity framework? All right. Entity framework, which is an object relational mapper for .NET. And the other is domain-driven design. Who's familiar with, has heard of, or even using? Who's actually doing like DDD in their projects? That's awesome. So now you might think domain-driven design and entity framework are antithetical, like, you know, they would have nothing to do with each other, because classic domain-driven design says, you know, you're focused on your domain. Do not think about data access. It has nothing to do with designing your software. It has to do with persisting your data, right? The two separate things. Oh, this is looking very hopeful. What did you change? Oh, that is mine, yes. Oh, thank you, magic miracle people. Yay! All close. Okay, we're close, we're close, we're close. Anyway, so every time a new version of Entity Framework Core comes out, what I do is look to see if there's scenarios where Entity Framework Core makes it easy to use that as a mapper to go from domain to persistence, so that we don't have to worry about explicitly creating a separate data model. So I'm just going to back up. So there's Vermont. Yes, so those of you who know Entity Framework might be familiar with the fact that I've written 4 books, although I haven't written one in a while, because once I started doing Pluralsight, I prefer the doing the videos, like those, and they weigh less too. Like videos on the internet don't weigh anything like huge books do. But I've done 21 courses on Entity on Pluralsight, not all Entity Framework, but quite a few. So I keep at it because Entity Framework keeps getting more and more interesting and better. So instead of going, oh, I'm bored with Entity Framework, I'm gonna go do something else. I do lots of other things, but Entity Framework continues to be interesting. So I continue to work on it and continue to share. My most recent course is Entity Framework Core 2.1, and with a focus on what changed, what got added, what was better since the 2.0 release. So that's what's going on with there. So in addition to Entity Framework, some of you may know, I also have a great passion for domain-driven design, which is 15 years old now. We're in the DDD community, we are celebrating that a little bit. And not only what Eric Evans brought us by giving us domain-driven design, but all of what's happened with the community and how the community has brought it forward and evolved it and added to it over the years. So with domain-driven design, the most important word is domain, right? We focus on the domain. We focus on the business problems, not on other cross-cutting concerns. Data persistence is even one of those cross-cutting concerns, unless you're building the next Dropbox. Is anybody here building an application that is all about persisting and storing data? Right, so if you are, then that is your domain focus. But usually storing the data is secondary, important, but secondary. So with DDD, we focus on the business problems. We don't let the problems of the data structure and data persistence impact or make dirty the things that are happening in our domain. So you just focus on the core domain. When I talk about DDD, especially with Entity Framework, and and eventually getting that data in there. I focus on half of domain-driven design, which is referred to as tactical design. But I always want to make sure people are aware that strategic design is the other very important half of domain-driven design. And strategic design is really when you're learning about the domain and doing analysis, deep analysis, working really, really closely with your clients and the domain experts at the clients, identifying subdomains and boundaries around them, and creating a language for each one of those subdomains. We call them bounded contexts. So within a bounded context, it's like its own ecosystem, its own software. And then tactical design is when you're really implementing the discoveries that you made. And then we have patterns, coding patterns, architectural design patterns that we follow when we're doing that. So I'm more focused on the tactical, but I think it's really important to always remind people, especially those who are introduced to DDD through me, when I am focused on Entity Framework Core, I want to make sure people understand it's not just about how to do these mappings and how to design the architecture of your software, but DDD is a much bigger picture. In tactical design, within our bounded context, when we're working on a particular domain, this is a mind map of the portion of DDD. Well, we've got a huge mind map of DDD, and this is the subset of that, which is focused on the tactical design. And we have entities, and it's just a coincidence, kind of a coincidence. Entities in DDD are not, that doesn't mean they are the same definition as entities in Entity Framework, except what they have in common is they have identity. That's what entities are about. But we also have value objects, we've got aggregates, which are graphs of data that belongs together, transactional. And what I want to do is look at some of the patterns that we use when we're designing using the tactical design and see how Entity Framework Core helps us map those things directly through to our database, especially to a relational database, because that's what I know the ORM is for. Except I'm actually in the middle of writing an article about the upcoming Azure Cosmos DB provider for Entity Framework Core. So we're going to take advantage of all that we know about using Entity Framework and DB context and be able to map to a NoSQL database. So it's kind of a funny thing to do. Anyway, so with DDD, we focus on the domain. We don't worry about the data model. We don't worry about the schema of the database. They're completely separate things. The nice thing is we know, at least I know, and this is why I do a lot of research with Entity Framework to help other people, is that it's okay to focus and forget about how you're going to get the data into the database, because we know that we have ways to do that. We know we have the patterns. So what I was saying before, my friends finally got the video working. Thank you. Is that classical domain-driven design says you design your domain model, you design your data model, and then you map your data model to your database, but you don't map your domain model directly to the database. So a lot of people get upset when I talk about using Entity Framework Core directly from your domain to your persistence layer, because they don't see that EF Core is the mapper. When the DB context at runtime creates a data model in memory, so it's doing that for us, right? And that's what we're using EF Core for. Now, EF Core won't always be able to do it perfectly, right? So we have ways. EF Core can do a lot of things through convention, so it just works. There are times when we can still have our domain models. EF Core by convention can't really get the data into the database the way we want to, but then we have mappings that we can apply, like in the Fluent API. I prefer the Fluent API over using the data annotations. And then, so we can do that, and there's a lot of cases where it just works, but there are times where it still isn't going to work, right? There are times where you're really running into that brick wall again, and it's time to make the decision between putting logic in your domain model to make Entity Framework Core happy, right? No, like that is totally against like the whole idea of reducing complexity, right? That's what DDD is there for, to get us to think and focus on making our lives easier. So by adding that logic in to make EF core happy, now you're adding side effects and problems and everything. So there are times when, you know, you do just need to do this, right? And so use a mapper between your domain model and your data model, and then you can use EF core as the mapper to the database. So EF core, who's using EF core in production? Excellent. 2.0, like 2, you're on the new stack. Yeah, because the 1.0 stack of EF core and .NET core, that was more for people who like bleeding edge, you know, don't mind so much, not everything being perfect, because it's just so nice to use some of the new stuff. So that came out a few years ago now, and even EF core 2.0 came out last summer. I can't believe it's been that long. And then 2.1 came out in June, and 2.2 is going to be out very, very soon, I'm sure. Connect, probably. I mean, that's just an educated guess because that's what they did the last time at Connect and the time before at Connect. So it is an educated guess, but I feel very well educated. So I'll be using 2.1, 2.2 preview, but it was really 2.1, like each iteration of EF and EF core has gotten us closer and closer to be able to get through to the database and back and forth to do our persistence without having to go, no, you know, got to use a data model. And each time a new version comes out, I research to see, you know, what else we're going to get. So 2.1 had some even, you know, 2.0 had some great new innovations. 2.1 had even more. And, you know, 2.2 is going to have even more. 3.0, we'll see what they're going to do with that. I know they're going to make some things that already exist, make them work better. So what I'm going to do is show you code, because, you know, I like to code, and I like to look at code and talk about code. So this is the domain model that I'm using in my demos. I have a team. So this is an aggregate, right? This is a graph. Everything works together in a transaction. So I've got a team. So it's like a sports team, football, well, soccer, right? In America, it's different football. So soccer team is kind of my focus, but maybe you can use it for anything. So a team has a collection of players, which come and go. A team has a manager, which can come and go. A manager has sometimes worked with lots of different teams, so we keep their history. Teams have uniform colors. It's very important. They don't change very much, but, you know, sometimes they do, and they I don't know. We watch American football lately, and we're astonished by some of the colors, the pretty colors that they're wearing while they're going and killing people. Like, just I don't know. It just seems kind of funny. Sometimes I think they look like Teletubbies. So, and then another important object we have in my model is one called the person full name. So, which I'm using in a few places, as you can see. So what I'm going to do, the model won't be like a perfect DDD when you first see it. So what I'm going to do is show you the model, and then I'm going to start evolving it little by little with some nice patterns from domain-driven design, explain the pattern a little bit, you know, given the amount of time we have, and then show you how Entity Framework, either by convention or with some help using the Fluent API, allows us to do that mapping. And also, you know, show you some of the little problems we might run into along the way. I do want to make sure you understand a few things before we look at the code. First of all, one of the reasons I love domain-driven design is because it aligns with my own, I coined this term, I'm pretty sure, although who knows, I felt like I did, with my own design pattern called ADD-DD. Now, I don't know if this translates into Czech, but it stands for Attention Deficit Disorder Driven Design, right? And I was just at AuraDev 2018, but I realized that I used that joke first 5 years ago at the same conference. But it's so true because I am a control freak, right? And that's pretty typical for a lot of people who do programming. And when I design my domains and my objects and my classes, I want people to use them the way I design them. I don't want them to use them any other way. I am a control freak. So the DDD, some of those practices really aligns very nicely with that because I want to do that. The other thing I want to point out is as I go through some of these different patterns and the mappings, I was trying to organize them a little bit. So I came up with these little icons you'll see on the slides as I introduce each of the different patterns. So some of the patterns I'm doing are about protecting the aggregate for the ADDD pattern, right? Making sure nobody does things and makes the aggregate invalid. Another is where I'm pointing out mappings that are helping us so we don't have to put entity framework logic that makes entity framework happy into our classes, right? So that's the entity framework debris and cleaning it up. And another is patterns that you can use when you're designing to reduce potential side effects of the code. Again, that gives us a true path and follows my ADDD also, so we don't have side effects. The other thing, I'm not going to, just in order for me to show you as many things as possible, I'm not going to be running them and debugging them and testing them. I like to think that everybody trusts me, that I'm not lying to you and pretending things work when they don't. So my process has been, of course, to make sure everything builds, and also to make sure that DB context is validated. I'm sure that you've had code using Entity Framework where everything built properly, it compiled, but then at runtime, Entity Framework was having a hard time building the model or something. So I can validate the DB context, and I'm doing that. Since I'm using Visual Studio Code, I happen to be using the CLI, so it's, this is the CLI method for that. And I also have a whole lot of tests. I have tests that are specifically unit tests for my business classes, and I also have integration tests with Entity Framework to make sure Entity Framework, not that it understands what my intention was, but that the way I expressed my model is how Entity Framework is interpreting it, right? So I have integration tests to make sure. So I won't be running all that, but you will see, if you download the code, you'll see all those things. So the first pattern that is really important, and again, I should have just called this one the ADDD pattern, which is about being able to encapsulate scalar properties. So Entity Framework Core introduced the ability to have backing fields in our code, and it's able to recognize them. So we don't always have to have public properties now. So if we can hide properties and have a backing field, and there's convention by which Entity Framework will understand a backing field compared to some things we might need to do to help it along a little bit. So let's see how, sorry, we did shut down Visual Studio Code in order to get everything working. So a moment here to get back in. Open up. Okay, and I don't want to be at the starting point. I'm going to just go right into here. So if I had spent some time showing you the starting point, it was the code before I'd started implementing some of the patterns. So I've already implemented the backing fields, added backing fields in here. So going from having just a public property here to, yeah, that's really okay. Thank you. I'm just going to escape. I should be able to, okay, so I'll just, I won't be able to slide back and forth. Oh God, my resolution, I can't see anything. Dude, come on. Okay. Good back there? Most important is that I can see it. I do have glasses on, but maybe sometimes I need bigger ones. So what I had done was, rather than having a publicly available property. Now I've really constrained things around this team name property, and I've introduced a backing field team name. Now by default, by convention, Entity Framework will recognize this because it's the same name, right? So if it's underscore, right, and it doesn't matter about the capitalization, but the name matches the property. So when Entity Framework is materializing data, it will be able to, even if I've got I don't have a setter anymore available on team name, right? There's no setter. So Entity Framework materializes data from queries using reflection. But it still needs things to be publicly available in order for reflection to find it. So reflection isn't going to find this property. Now normally reflection, Entity Framework knows how to find the backing field, but and populate it that way. Except, so that would work by convention, except, I'm doing DDD and really constraining things and encapsulating and protecting, and I've made this private, so now even reflection can't find it, okay? So by convention, if that was public, if this backing field was public, Entity Framework would just find it, everything would be fine, you wouldn't have to do anything special. But because I've made it private, it would fail. However, it's possible to use a mapping. So you're not going to, I don't expect you to memorize all these things. I just want you to be aware that they exist. I'm going to show them to you, but you can look at the code later. And get to that point where you're like, I know exactly how this is working. So what I'm doing is telling it, that property, by the way, has a backing field. So that's a new method in EF core that we didn't have in EF6, has field. And I'm using a magic string because that is a private field. And even here, I wouldn't be able to use a lambda because it can't find it, right? So I'm just using the string to express it. So now I've completely encapsulated the property. I've got a private backing field. The only way to populate that, based on my business needs, the only way to populate that is when I create a new one, and my constructor in the team class has me pass in the team name. And that's, we can sit here and think about all the ways that that is really bad logic, but it's really good logic for being able to demonstrate that I've completely encapsulated this backing field. So that's my bigger point. So when you need to do that, it's possible. So the mapping solved that problem. So this is going to be a little funnier now, going back and forth. Hopefully I just go here. Okay, yeah, I'm just going to have to be paying attention to how to do that. So the next one I want to show you, this was even much more important. We never had a way to do this before with Entity Framework, is that now we can encapsulate collections and really protect our collections, to protect our aggregate. So the way you can do this, there's actually a couple of levels of this as well, some that work by convention, and then when we want to go even further, okay, I see that you're not seeing that, so I have to go back here. I have to escape. I have to, oh, sorry, this isn't like smooth and magical. Okay, but you can see it, so that's all that matters. So I've got all these different examples in different branches, so if you're downloading the code, just be aware of that. So I originally had a public list of players. I had a private setter on it, so I couldn't just replace the list with another list, but it was still possible to go directly against that property and add new, add players or remove players, right, by using, the list.add and list.remove or whatever. Now, I didn't really want that to happen. I have this really, it looks dense, but I have a method in here which follows my business rules for adding a player, right? And I want any developers using my objects or my APIs to use that. However, it was possible for them to also go into that public getter of the players collection, right? So I had to say, please remember, don't use that thing. But that was really, really frustrating. So the first level of protection here is that with Entity Framework Core 1.0, lists and collections, the pattern that we would, forget about EF Core for a minute, the DDD way, like the way we would write this when we're thinking about DDD and encapsulating, is to use an I enumerable. So nobody can affect it, they can only read it, right? That's the pattern that we would use. The problem was Entity Framework could never deal with that because Entity Framework was never able to materialize results if we were using projection that brought them in or eager loading. So if we had team and players, it literally could not see, because if I used an enumerable, it could not see that property at all. So it didn't recognize enumerable. So the big new thing is that it recognizes enumerable. So by default now, by convention, I can do this encapsulation. I can make it an enumerable so that my API users are forced to go through my add player, and if I had a remove player to move players out, they're forced to do that. So that was an amazing improvement. But there's another level of this, which is, what if I want to have a backing field for that? Right? So I can have a backing field for a collection also. Again, if that was public, no problem. Entity Framework sees everything. But what if I want to make it private? So I'm really purely, there's no way for anybody to touch this property without going through my methods, right? So it's completely encapsulated. So the only problem I'm creating that goes beyond Entity Framework convention here is that, like with the scalar property, I've made this private, right? So there's just no way of getting to it, and a reflection can't see it either. So again, this is something you can solve with mappings, which are here. So it's this pair of mappings. I mean, I could have done them, I could have combined them into one line of code. So the first thing I'm doing is I have to find that navigation. Right, so I'm able to find team players. So I'm identifying the navigation, and it returns, EF Core is returning, what is this var? What type is it? I don't know. The type that it's returning as it's looking at the metadata of the model is a navigation. And then navigation has a method called setPropertyAccessMode, and I just say, look for a field. Now here, I'm not saying what the name of the field is. I'm just saying, look for a field. That's how you're going to get at it. And the reason I'm able to do that is because the field name matches, right? It's underscore players and players. If the field name didn't match the convention, then I would have to say, look for a field, and, look, you're going to be using a field. You still have to say that. And then I have to tell it what the field name is. Has field, or I think works there as well. So you can solve, so I've really encapsulated that. I've made it private. Nobody can touch it, but I've done so much that not even Entity Framework Core can touch it. So I can go into the DB context and make that change. So all of my mapping solutions are happening in the data layer, the DB context. I don't have to change my domain model. I can write my domain model the way I want it to be written. Okay, this is a biggie for me. Value objects. The reason this is a biggie is value objects are one of the most interesting and really critical pieces of an aggregate that we're using with DDD. It's also one of the most hard concepts for developers. And you know how I know that? Because it was really, really hard for me to wrap my head around a value object. I think it took a year, but it was a year where I had heard or read 5 different explanations of what a value object was. And it wasn't until I heard that 5th one that I finally had my aha moment. All right? And it wasn't because the 5th one was the only one that was right. It was because I had to put together all the ideas from the different examples, and then all of a sudden it all, together they all finally made sense. So I'm going to spend a little extra time talking about value objects before I show you what entity framework is able to do. Now, EF1, well, maybe we call it 3.5, 4, EF5, EF6, they actually had the ability for us to map these value objects, to define value objects in our model, and entity framework was able to map them and persist them and restore them. So what happened was EF Core 1 came out and they weren't there, and we're like, oh no, like we're going backwards now, because it was so critical for anybody who's doing DDD. Value objects are really, really important. But then with EF Core 2.0, we've had a solution again for mapping. And what the team had done, rather than just duplicate what they did in the first version, the first set, entity framework itself, not EF Core, rather than duplicate it, they knew it was going to limit them with respect to what they wanted to accomplish with EF Core, so they spent a little more time thinking about it, and they brought it back to us in EF Core 2, but now we use a mapping called owned types. So we're able to do that, but I do want to make sure you understand what value objects are. So this is, part like helping you understand DDD and helping you understand about entity framework. So a value object in DDD has a very specific definition. This is part of it. Because I'm gonna show you something about this part, and then I'm going to show you and then make sure you understand the other attributes. So an important attribute of a value object is it doesn't have an identity key. It's not an entity, right? An entity you track using its identity key. A value object is a class that does not have its own identity. It's dependent on another entity. It's just a property, right? But it's not a scalar property. It's a property that leads to its own object, okay? But another important piece of that is that a value object, it does have identity. Its identity is defined by the composition of all of its properties, okay? As opposed to having an extra value in there that's just like, a GUID or an integer. The way you can tell one value object from another, one instance from another, is by looking at all of its properties, okay? So here are a few of not all 5 of the examples, but a few different perspectives on value object, and I hope this will help you at least get a little understanding. So string is like the ultimate perfect value object. We use strings quite often. And string is immutable, right? Because if you change one letter of a string, sorry, this is in English, but hopefully they're simple enough. I do not want to play this game with Czech, just because I do not speak it well. So, but you change one letter in there, and it completely changes the definition, the whole definition of what that is, right? Or, change another letter. We go from a rat to a cat to a car. So we're in, first grade 5-year-old person English lesson here now. Another really important type that can be used as a value object is money. So it's really, really important in financial systems. Who here works in financial systems? Yeah, so it's really important. I think as I've learned more about different technical communities, I think if I was in Lagos, Nigeria, every single person, because that's like their big tech community is famous for. They're all financial systems. So I'm so sorry I didn't change this when I went from Sweden 2 days ago to here. This would be much more dramatic, I think, this would be much more dramatic if I was using the local currency, because the difference is so big. But in Swedish crowns, I know there's a few Swedes in the room. In Swedish crowns, if you had 45,000 Swedish crowns, what you can get with those, like the commercial version of a HoloLens, is much different than what you could get with 45,000 US dollars, right? So it's the combination of those two values that really give us the identity of what that is. I'm not saying that 45,000 SEKs equals a HoloLens, it just equals that value, right? So just changing one of those properties completely changes the definition of what what this value object is. But, you know, imagine adding yet another property to there, the moment in time, right? You think about financial systems and stocks and the values comparing different monetary units, right? How just a moment in time will change what the definition, what that meaning of that object is, right? So that's kind of a quick look at what value objects are. What does it look like when you define a value object? So remember, it's immutable. It doesn't have an identity, so you're not going to see any kind of key value in here at all. This is the person full name that I have in my code, but I thought it was easier to show you this way. So the only way to change this, it's immutable, so I populate all the properties in the constructor, right? That's the only way. So once I create it, that's it. You can't edit any of these things. So I've got private setters here, right? Another is, you know, why would I even do this? Well, a name is something I'm going to be using with a lot of different objects in my domain, and I have the same rules I want to fulfill for the name every single time. So I'm encapsulating this in this object. So here are things I want to be able to do: is name, return a full name, return a reverse full name. Another important aspect of value objects, besides its immutability, right? The identity is the combination of the first and last name, is that in order to ensure that when you're comparing things, that comparing different instances, that you are comparing all of those properties. So you have to overwrite the equals to make sure that equals is checking the equality based on all of the properties of these. Now, there are classes you can inherit that have, use reflection to do all that for you. So you don't have to, if you're thinking, yeah, but I don't have two properties, I might have a lot of properties, and that gets really clunky. So you could use reflection, although there's a point at which, reflection to create something generic to give you these attributes, but there's a performance issue that you want to keep an eye on, right? Because using reflection is more expensive. You also have to overwrite the get hash code. You want to be able to do override operators as well to make sure. So that makes sure that you're comparing all of the properties when you're doing comparisons. So that's just a simplistic look at what a value object looks like. So thinking about this list of value object attributes and getting back to thinking about Entity Framework Core, Entity Framework Core has this new mapping called owned type, and what owned type looks for is anything that doesn't have an identity key and is being used as a property. Then it will know how to map it. So the requirements for owned type are a subset of value objects. So if I've defined a value object, then I can use it as an owned type. Okay, and Entity Framework will understand it. Now, Entity Framework will never understand an owned type by convention. You always have to map it. And this is the mapping. It's, oops, I forgot a period in there. The owns one method. Okay, the owns one. So the entity that is the entity that you're using, so in my case, team, and then the property is the property that you're using. So let me show you what this looks like in my code. And yes, I escape, and then I have to wait, and then I have to alt-tab, and there it is. Okay, so I'm going to switch again to this new branch, which is value objects, which is where? There. So if I look at player, player has a property, a person full name property. I'm calling it name factory, and I can't edit that. Oh, I have that public. Why do I have that public? Don't look at that part. I forgot. Like, why is that public? Doesn't make any sense. But what I'm doing also here is making sure I'm exposing .name. I'm exposing the name of the person full name, right, as a property of player. Read only. It's only got a getter. So. So I'm just kind of trying to demonstrate using that. And whenever I want to change the name, if I can't just edit the name, I have to create a new name. So here I'm just using the constructor to set up the name of that. So what does person full name look like? Pretty much like what I showed you on the slide. I've got it. I'm going to point out very, very quickly. There's a little extra code in here because there's something that currently in EF Core 2 and 2.1 and 2.2 that Entity Framework Core does not do well. And I thought long and hard about it, you know, like, is this a point where it's failing and I have to have a data model? No, I'm not, you know, I'm making the fix for this problem in my value object, but not in my real domain objects. I'm not doing this extra work to get around an entity framework problem. I'm not doing it in the player. I'm not doing it in the manager. So this fix is coming. But the problem is Entity Framework Core does not let you have a null owned entity. So what that means is, in this case, it's okay. Why would I have a player without a name, right? My player and my manager are always going to have a name. So that's not a huge problem here, but there might be scenarios where you have value objects, and it makes perfect sense for some of your entities to leave that property null, you know, just not to populate it. But the owned entity mapping doesn't allow it right now. So I just have a workaround. I'm not going to show you more about that workaround. I wrote a whole article about it earlier this year in my data points column in MSDM magazine. And the workaround is here in the code. So I have the value object, and then in the context, I have mapped for each of my entities. So player has a property called name factory, and I just want you to know that's an owned entity. So Entity Framework will know how to do the mapping, right? And the way it persists is the way it used to do it with complex types in Entity Framework. By default, it will take the properties, so the first name and last name of the owned entity, and put them into the table where the rest of the player is. And in the manager table, you'll see, you know, all the manager properties and a first name and last name property there. So that's the default. There's other ways you can configure that. So you do have to let Entity Framework know what to do with this. Otherwise, it'll say, you know, you're using this object, but it doesn't have this, you know, person full name, but it doesn't have a key. So the DB context fails, right? So the owned entity is really important. I should just do that as a whole talk. I love value objects. So the other thing I want to say about value objects is, with DDD, what I learned, and I learned from other DDD experts, is it's probably more common that you'll have a value object than a one-to-one relationship, right? Because it's almost like a one-to-one relationship, except they don't have a key to, you know, do a foreign key, a primary key, foreign key constraint relation between the relationship. So every time you look at something that you think might be a one-to-one relationship, step back and think that, you know, do I really need an identity? Do I really need to track this separately? Or is it really only make sense as part of this entity and be a value object? And it's much more likely that something is going to be a value object than an entity framework. So you really want to, you would default to thinking, okay, first, it's, you know, by default, I would think that it's going to be an owned entity. I want to point out that right now we don't have support for value object collections. The team was working on it, the Entity Framework team, not the football team. The Entity Framework team was working on it, but they've pushed it off to 3.0. But we're eventually going to have an owns many mapping as well, along with the owns one mapping. I want to point out this is removing EF debris, right? By convention now, Entity Framework Core thank goodness, is so much better at recognizing one-to-one relationships. So the times where you really have decided, yes, this has its own identity, it's going to be a one-to-one relationship between these two entities. So in Entity Framework, if you had a one-to-one relationship, you had to put navigation properties on both ends, which often made me mad, because quite often I didn't need, I might need to navigate from the parent to the child, or the principal to the dependent, but I wouldn't need to navigate the other way. And I didn't want that navigation property to point back. I just wanted like a foreign key ID. But Entity Framework required us to define, to tell it which one was the parent, which one was the child. We had to map that in the context, and in order to do that, we needed the navigation properties, right? So it was just all kinds of annoying because it was making me do things to DDD, my domain models, that I didn't want to do, but they just finished early. I guess we still got time. I got so much to tell you still. They had, yeah, it made me do things in my domain models that I didn't want to do, right? Which is, and it added more complexity and created some problems. So I'm so happy that by convention now it allows you to do that. And this is just a, a little look at the difference, right? We had to have, oh, by the way, somebody finally told me that it doesn't work to do that. I did that for like, what, 5 minutes yesterday? And last night at the party, somebody told me, oh, by the way, that whole laser thing you thought was working, it wasn't working. So anyway, so, this is what it looked like in EF, right? We had to have the navigation properties on both ends. We had to do the mapping. Now, if it's just basic, it'll recognize it by default, which is really nice. But also, we can encapsulate that. So, for example, if I went, back. Right, so for example, in this, in here, if in the dependent, I wanted to make that, in the dependent class, if I wanted to make that foreign key property private, and protect it and have a backing field for it just to make sure nobody just goes in and edits the foreign key property without going through my business logic, particular methods, it's possible to do that mapping as well. So I'll just give you a quick look at that, which means all these funny keystrokes. But I'm happy they're here. No, there. Using these different branches is like really brilliant, but it feels a little time consuming sometimes. So here, just so you know, what I've done was, my one-to-one relationship here is between a team and a manager. And I've encapsulated the manager. So the property is private, and it does have a getter, so I can always get the value back, but the focus here is that I do have a backing field. The backing field is private. And I also can always return the manager name, right? Like, so I can drill through that. But the backing field is private. So again, Entity Framework wouldn't by default be able to find that when it's materializing data. So I just have this mapping here. First, I have to identify the relationship so it knows what I'm talking about, this one-to-one relationship. And then I'm just saying, by the way, here's the foreign key, right? And I'm using a string, again, because I can't use a lambda because it's a private property. So there's just a mapping to do that. Where are we? Okay, so we can do that. I just want you to be aware of this. It's not really about DDD, but as long as we're talking about one-to-one relationships, I do want you to understand that right now, EF Core, if you want to have a many-to-many, you have to have an explicit join entity. If you were looking at a relational database, there's always a join table between two tables that have a many-to-many relationship, right? So we have to do the same in our code, in our mappings. You have to explicitly map the key of the join entity because it's a composed key. And you have to be really careful how you're coding it, right? You have to pay attention to all those relationships. So it's a lot more explicit than using the nice magic. So that's not a happy situation for some people. I'm just letting you be aware of it. I'm only the messenger. Okay, so another really important capability, oh, come on. Another really important ability is value conversions. So I just want you to understand what a value converter does. We can configure this right in the DB context. It gives us the ability to use the types we want in our domain models and not having to worry about whether there is a way to map those, whether there's a data type that aligns them. Color is the perfect example, right? And if you were looking in the code in the uniform colors, you'll see I'm using colors as the properties of uniform color. So what the converter does is we use the type we want. In the converter, we don't tell it about the data type, but in the converter, we tell it a different .NET type. So we say we have color, right? But when you're persisting it, change color to a string, right? Because color struct has a method that you can just change to a string, and then go ahead and persist. Well, Entity Framework goes, oh, string, I know how to persist string. Then when it comes back, whoop, I'm trying to do this without my clicker and I'm going all over the place. Then when it comes back, we're doing a query, it gets a string back. So I have another, a part of the value conversion is there's another piece of it that says what to do when you're bringing the data back out of the database. So it says, all right, well, this is going to be a string. Use the color structs method to create a color from a string, use the string, and then it's able to just materialize the color. So the value converters are not converting from your types to data types, it's converting from one .NET type to another, but the other one is one that Entity Framework knows how to persist into your database. So those are really, really important. There's a few ways to do it. So has conversion is the critical method here. What you pass into has conversion can be on-the-fly definitions, pre-created variable, or even a class that you've created. And Entity Framework Core does have a whole bunch of built-in conversion classes. The last thing I want to make sure you're aware of is shadow properties. This is so awesome for storing audit data. It's also something they're taking advantage of for doing the Azure Cosmos DB. I'll show you really quickly. And my apologies to any of you who really needed to eat lunch this early in the day. Just have a, there's not going to be a line left when we get there. But this is worth seeing. So, and I came all this way. I'm sorry. Okay, so value conversions. So I want considering the not value conversions, shadow properties, considering the audit data example. Okay, so there's all kinds of scenarios where we want to track things like, when this row in the database was created, when this row in the database was modified, right? And we have to put that into our domain logic, even though it has nothing to do with the business, right? And now we have extra problems to solve. It's getting in the way. It's adding side effects, right? We have to deal with that all the time. So what shadow properties let us do is put this whole problem of, whether it's audit data or something else, data that you want in the database, but you do not want in your domain model. So we define and control all of it in the DB context. And here's how you do it. When you're working with a model builder, you just start saying, hey, the team entity that we have, and by the way, the property that it has called created. So we're pretending that it has a datetime property called created. And because we've said that, even though it doesn't really exist in the domain, when Entity Framework is building that in-memory data model, when it's reading through the DB context, it's going to add it to the data model in memory. So the DB context is aware of these properties. Now I'm just doing it here for one, I guess I should point to my screen. I'm just doing it here property by property, and one for, I'm doing it explicitly, but you can have generic code to add this to like every single one of the entities and make sure that you don't put it into the value objects. So you can have generic code to do that. So now the model is aware of these properties, and they will get persisted into the database. So you'll see those columns in the database. But how do you populate them? You can populate them directly in the DB context. The DB context is aware of it. There are ways you actually can query that data out if you do need to get it out like, usually you would just use it for reporting. But if you're using Entity Framework and you're writing a link query, there is a way to get access to it. But what's more important is knowing how to populate it. So we do that by overriding save changes, and then I can just look, through the entries that the DB context is aware of when I'm saving changes, look for any that's added or modified, and then put the last modified value in there. Look for anything that's just added, and I can put the created stuff in there. So now it's in the database, and we can do our reports and everything against the database without having to worry about putting these things into our domain model. I really, really love that. So just a little wrap up. I want to make sure you're aware of a couple other things. So are we back? Yeah, okay. So here, just a quick list of the patterns you saw. So when you look at the deck, you can remember all those things. And I also want to make sure you're aware of query types is something that was introduced in 2.1. We can have objects without keys, and actually Entity Framework will understand them, so you can properly, like, no tricks. You don't have to do workarounds to map database views. There's all kinds of cool stuff you can do with that. I wrote about it in an article in MSDN Magazine, and I also dedicated a whole module to it in my EF Core 2.1 course on Pluralsight, so you can learn more about that. Spatial type support is coming in the 2.2 release, which is imminently being released. You might have noticed, again, this is something I dedicated a whole module to. You can actually have parameterized constructors, and in a lot of cases, not all of them, Entity Framework will be able to discover those when it's materializing data, so you're not in the situation where it says, I can't find the constructor, because you still have to have a parameterless constructor available. So it will recognize that a lot. Also, you can have derived types that you can include. We've never really been able to do that before. So, these are things that how I want to design my my domain models. The Entity Framework was giving me problems before in order to deal with them. So now it's letting me do more and more and more things. So when you're writing your code in your domain, don't worry about Entity Framework. Just forget about it, right? I mean, not really, because we love Entity Framework. But don't worry about what it is and isn't going to do, right? That's going to be a mapping problem. Like, solve that problem separately. Know and trust that a lot of these things will work by convention. Some have mappings. Some you're going to find, yeah, it's just not going to work. So I either have to make a decision of, putting logic to make EF Core happy in my domain, which we don't like to do, or, at that point, it might be worth it to just go ahead and create a separate data model. And when it doesn't work, right, that it's up to you to make that decision, right? Don't listen to people like, don't ever do this, you're a terrible programmer if you put that EF Core logic in your domain, right? You know what you need to do. You understand you've got some good guidance, and you can make good decisions with your great experience to do it. So that's, yeah, I've got lots of stuff on this topic. Here are some resources. Go ahead and take a picture of that. But this deck and the demo are available on my GitHub account. So it's under 2018 DDD mappings. You can find that. Okay, now you can go eat lunch. Or should I say, go stand in line. Thank you so much. And thank you so much for letting me come to Prague. It's such an honor.